You are now muted.
7.2. If we have axial compression force, okay, we use this formula, and you know AG is a gross area measured in units of inch, and NAU is axial force in terms of pound. If your axial force is tension, you must use up this formula. They are same, but only on the nomenclatures they have difference, okay? But maybe you use on NAU. If it is axial tension, the sign of NAU is negative, okay? And for circular member, the area B multiplied B taken as product of diameter and effective depth, okay? And also you can use up effective depths about 0.8 times diameter. For compute of the cross section, the circular member. And for shear and contribution of steel, the use of three basic functions. One, carries a parts of external shear force, restricts the growth of a diagonal crack, and holds the structural reinforcement bar in place so that they can provide double action. If steps are provided as closed bays, they also provide confinement to concrete in compression zones. A number of modes are available for staying contribution of stirrups to shear capacity, and popular models are truss, analog, and compression story. Essentially, the compressive force are taken by concrete and steel provides the tensile force needed for equilibrium. If the steel stirrups with area are provided at a spacing of S, then contribution of steel, you can use of these formulas for compute of contribution shear for steel. Also, is done in a state of equation. You can use of this very summary, and it is better because your stirrups are vertical, okay? And this equation you can compute it for contribution of steel stirrup and stirrup spacing. This is very important. Mr. Muhammad Mahdi Saleh. This is very clear. Okay, they are in here. You can see all formula about shade force. Okay, that you use for design of concrete beam. Previous you studied this formula. And about the limitation on spacing and maximum contribution of reinforcement. Also for stirrups. Okay? At present diagonal crack, the most restrictions are placed on stirrups, okay? And spacing cannot be less than 25 inch. You must use of these two conditions, okay? And two condition is very important. D per 2 and D per 4, okay? Okay, spacing stirrups. You must use of these two restriction, okay? And contribution of a silk should not exceed of 8 BWD root square resistance of concrete. Okay. And also stirrups should be provided a V more than 50 BW as FLY, and you know W is area of all vertical legs of reinforcement, okay? And also, you know, last two provisions are provided as a precaution against brittle failure. This is very important. These last two provisions are provided as a precaution against brittle failure. They are very important. But composite material is very important, and the behavior of composite material for shade stranding, okay, studied by several researchmen, same Mr. Chajes and Khalifa, and also by McCurry and Malam. Also Mr. Norris in 1997 his research about composite material for shade. A number of configuration can be used for shade trimming, okay? And in here we study the configuration are briefly discussed in following section, okay? In this part about sheets bonded to web. This is very important. Composite material can be placed on the sides of that. Refer to figure. You will see, inshallah. The most effective way is to integral section. Again, refer to figure. Even though theoretically this is the best option, it may not be practical in most cases because taking two composite through to slab will be very expensive. In most cases, it will also be impractical because of the failure hovering on top of the slab. Please attention, this sentence is very important. One, both expensive, and another, it will also be impractical because of the floor hovering on top of the slab. This is very important. A more practical approach is to cover the interverb as shown figure, when this type of verb referred to as U verb provides good anchor. Okay, this is very important. These verbs are not as effective in the negative moment region because they crack initial at top of the beam, and for positive moment regions, you verb are most commonly used configurations. This is very important, and provided the mechanic anchor at the junction of beam slab can considerably raise the effectiveness of the groove and place sheets in groove with and bar. Okay, this figure here you have various figure for marking transfer FRP reinforcement. Okay, refer to ACI code. Okay, you use up FRP and you can completely warp the beam. Also in here you use up 3 sides. Okay, UP warp, and in here 2 sides. But the figure A, it is better because you can confine the concrete and it will be ductility. Doctor, please, your verb means the ops should be or its anchor. Yes, okay. Mr. Nabil, figure A is very better, but in here the slab and beam are separated. Okay, okay, and okay, for but if you use or side okay, ductility is very little, okay, and behavior of beam against the force not good. الله إبراهيم مشكور القتلاتي. Okay, you can see here for continuous beam the use of reinforced concrete, and in here also we have composite material. Both they have a distance of together, okay, and a spacing of reinforcement of or can be applied as a continuous shade, or strips can be placed at designed spacing. You can see this example when prefabric plats or bar are used. The second option is only choice. This is this, and contour made provide better confinement. This is very important. Continuous VAR made provide better confinement, okay, but may not allow proper realized if it is suspected that moisture could migrate into concrete through uncovered areas. The second option should be used to avoid degradation at the concrete composite interface. This is better, but some may be used on this case if we have confoided. And fiber can be oriented vertically or at chosen angle to maximum to fiber contribution, okay? This can be done by shade applied in field and pre-fabricated system for fabricated plate and bar applied in this implied direction may be better because there will be more bond length. You can see this figure, okay? But using theta equal 90 degree, okay, by axial reinforcement. And in here you have a verb using theta equal 45 degree. In various primary direction you can use composite materials or FRP. Okay, in here also you can see that by using 0 and 90 degree. They are perpendicular together. And also in here the FRP are perpendicular together with various angle, okay, and by axial shear reinforcement. And there are anchors, okay, that the funded product and this may be not option unless very thin plates are used in here, okay. but if the use of FP, the contribution of composite to shell capacity is shown by VF, okay? Then concrete, steel, and FRP, they have contribution in total shell capacity VN, yeah? And VF depended on several parameters, include stiffness of composite, thickness of composite, compressive concrete, fiber, orientation angle, quality of ring used for bonding, and anchoring mechanism. They are very important parameters, okay? VF depends on several parameters, including stiffness of composite, thickness of composite, compressive strength of concrete, fiber, orientation angle, quality of resin used for bonding. They are very important, and anchoring mechanism. Okay? The failure of composite will occur either by composite rupture or by eliminations. In bad cases, failure will occur well better. The composite can be reached to fracture stress obtained in tension tests. This is very important. Okay, in bad cases, failure will occur well better. The composite can reach the fracture stress obtained in tension tests. This is very important. For shell contributions on composite, this is very important. Design approach is based on fracture of composite, and in order to approach use of a steel reinforcement in the sense of yield effect for steel effective rupture stresses is shown by FFE is used for computation. Okay, and Mr. Triantifuro dominated the reduction in fracture stress that occurs due to a stress concentration. Okay, if effective strain failure is epsilon. That we use of this formula. Okay, and you can compute the VF. Okay. And also, you know, OFF and DVF, depth of composite, and FS is spacing of composite reinforcement. And similarly between equation, okay, 7.5 and 7.12. Okay, you can see for these three cases, refer to ACI code, and you know TF is composite placed on back side, and WF is weight composite. Okay, this is very important. And this is very important for control of strain in FRP. We use of this equation, okay, for guaranteed to fracture of composite. Okay, use of this formula. I think it is enough for today. Inshallah, next week I will continue the remainder of chapter. It is enough for today. Okay. Which one of the students is ready for present of subject? چه زیبا صدای بلبل. Doctor ready to show or seminar. Okay. Mr. Saban Qasim. Okay, I will have your microphone. Mr. Salvan. Salvan Qasim. Your microphone is active. You can start your seminar. Please have you my voice, Mr. Salvan?
Hello, doctor. How are you?
How are you, Mr. Salvan?
I'm fine, thank you.
You can present.
Please give me 2 minutes for upload the PDF.
Yeah. It is also active for you. You can. Okay. Use option three. Use option for present. Okay, that's good. طبعا هياكل.
Hello, doctor, I'm ready.
Okay, very good. Okay.
Okay. We're going to speak about blast resistance building.
Okay.
This study prepared by Ali Ahmad, Ali Habib, Hussein Dakhil, Salman Qasim, and Yahya Abdul Wahab.
Oh. More than 10%.
Very. Table of contents. Number 1, abstract. Number 2, introduction. Number 3, explosion process for high explosives. Number 4, architectural of blast resistance building design. Number 5, structural aspect of blast resistance building design. Number 6, results. Number 7, reference. Abstract. The increase in the number of terrorist attacks, especially in the last few years, has shown that the effect of blast loads on building is serious matter that should be taken into consideration in the design process. Although these kinds of attacks are exceptional cases, man-made disguised blast loads are in fact dynamic loads that need to be carefully calculated, just like earthquake and wind loads. The objective of this study is to shed light on blast resistance building design theories, the enhancement of building security against the effect of explosive in both architectural and structural design processes, and the design techniques that should be carried out. Firstly, explosive and explosion types have been explained briefly. In addition, the general aspects of explosion process have been presented to clarify the effects of explosives on buildings. To have a better understanding of explosives and characteristics of explosion will enable us to make blast resistance building design much more efficiency. Essential techniques for increasing the capacity of a building to provide protection against explosive effects is discussed both with an architectural and structural approach. Introduction. Damage to the assets, loss of life and social panic are factors that have been minimized in the threat of terrorist action cannot be stopped. Designing the structure to be fully blast resistant is not unrealistic and economical option. However, current engineering and architectural knowledge can enhance the new and existing building to mitigate the effect of an explosion. The main target of this study is to provide guidance to engineers and architects where there is a necessary to protection against the explosion caused by detonation of high explosives. The guidance describes measures for mitigating the effects of explosions, therefore providing protection for human structure and the valuable equipment inside. The paper includes information about explosives, blast loading parameters, and enhancement for blast resistance building design, both with an architectural and structural approach. Only explosion caused by high explosive chemical reactions are considered within the study. High explosives are sold in form and are commonly termed considered explosives. TNT is the most widely known example. There are three kinds of explosion, which are unconfined explosion, confined explosions, and explosion caused by explosives attached to the structure. Do you hear me, Doctor?
Yes. Oh, very good.
Unconfined explosion can occur as an airburst or a surface burst. In an airburst explosion, detonation of the high explosive occurs above the ground level and intermediate amplification of the wave caused by ground reflection occurs prior of the arrival of the initial blast wave at a building. I'll show figure number 1. As the shock wave continues to propagate outwards along the ground surface, a float commonly called a match stream is formed by the interaction of the initial wave and the reflected wave. However, a surface burst explosion occurs when the detonation occurs close to or on the ground surface. The initial shock wave is reflected and amplified by the ground surface to produce a reflected wave. I'll show figure number 2. Unlike the airbursts, the reflected wave merges with incident wave at the point of detonation and forms a single wave. In the majority of cases, terrorist activity occurs in built-up areas of cities, where devices are placed on very near the ground surface. Figure number 1, airbursts with ground reflection. And figure number 2, surface bursts. When an explosion occurs within a building, the pressure associated with initial shock front will be high and therefore will be amplified by their reflections within the building. This type of explosion is called a confined explosion. In addition, and depending on the degree of confinement, the effect of the high temperature and accumulation of gases produced the chemical reaction involved in the explosion will cause additional pressure and increase the load duration with the structure. Depending on the extent of venting, various types of confined explosion are possible, as shown figure number 3. Show figure number 2, fully vented. Views number second views partially vented. Third views
Mr. Salman, we have not your song. We have not your sound. Can you active the microphone, Mr. Salman? Okay. Mr. Salman. Mister, your microphone is active. Mr. Salman.
Doctor, where are you going? I'm talking with you, but no, sir.
No. I have present.
I'm talking with you, but not answer. Okay. I'm continue.
Every sentence you present, I check it. Okay,
no problem. I'm continue.
Okay.
If detonating explosive is in contact with a structural component, following the arrival of the detonation wave, the surface of the explosive will generate intense stress waves in the material and resultant crushing of the material. Expect the explosive in contact with a structural product similar effects to those of unconfined or confined explosions. There are many forms of high explosive available, and as each explosive has its own detonation characteristics, the properties of each blast wave will be different. TNT is being used as the standard benchmark, where all explosion can be expressed in terms of an equivalent charge mass of TNT. The most common method of equalization is based on the ratio of an explosive specific energy to that of TNT. Dr. Mujtaba.
Yeah, I have your song.
Okay, please active the mic for Ali Ahmed.
Ali Ahmed.
Ali Ahmed Ghali Attaya.
Okay, Ali Ahmed, please.
Thank you.
Please wait. Mr. Ali Ahmed.
Last message.
Yes, Ali Ahmed Al Tajara.
Yes.
Okay. You can present. Okay.
Thank you.
Okay, Mr. Ali Ahmed. Mr. Ali Ahmed. Ahmed. Are you ready?
Salam, doctor.
Yeah. Assalamu alaikum. Assalamu alaikum wa rahmatullah.
Walaikum salam. Okay, I'll proceed
Okay.
presenting.
Oh, you can.
The explosion process for high explosives. An explosion occurs when a gas, liquid, or solid material goes through a rapid chemical reaction. When the explosion occurs, gas products of the reaction are formed at a very high temperature and pressure at the source. These high-pressure gases expand rapidly into the surrounding area and a blast wave is formed. Because the gases are moving, they cause the surrounding air move as well. The damage caused by explosions is produced by the passage of compressed air in the blast wave. Blast waves propagate at supersonic speeds and reflected as they meet objects. As the blast wave continues to expand away from the source of explosion, its density diminishes and its effect on the objects is also reduced. However, in tunnels or enclosed passages, the blast wave will travel with very little diminution. Close to the source of explosion, the blast wave is formed and violently hot and expanding gases will exert intense loads which are difficult to quantify precisely. Once the blast wave has formed and propagating away from the source, it is convenient to separate out the different types of loading experienced by the surrounding objects. Three effects have been identified in three categories. The effect rapidly compressing the surrounding air is called air shock wave. The air pressure and air movement effect due to the accumulation of gases from the explosion chemical reactions is called dynamic pressure. And the effect rapidly compressing the ground is called ground shock wave. سلوان حول للصفحة ما أقدر أتحكم من يمينك. حولت. Okay, doctor. If detonating explosive is in contact with a structural component, for example, a column, the arrival of the detonation wave at the surface of the explosion will generate intense stress waves in the material and resulting crushing of the material. Except that an explosive in contact with a structure produces similar effects to those confined or confined explosions. There are many forms of high explosive available, and as each explosive has its own detonation characteristics, the properties of each blast wave will be different. TNT is being used as the standard benchmark, where all explosives can be expressed in terms of an equivalent charge mass of TNT. The most common method of equalization is based on the ratio of an explosive's specific energy to that of TNT.
Okay, you can continue. This is very good diagram for pressure and also time, okay?
Okay, sir. I'm waiting for the slide to upload.
At T equals 0, you have maximum pressure, okay? And it is positive as. And after Ti, it is negative as.
The slide is loading, doctor.
Okay, this is blast wave pressure for floated for a given time. Okay, so yes.
The air shock wave produces an instantaneous increase in pressure above the ambient atmospheric pressure at a point some distance from the source. This is commonly referred to as overpressure. As a consequence, a pressure differential is generated between the combustion gases and the atmosphere, causing a reversal in the direction of flow back towards the center of explosion, known as a negative pressure phase. This is a negative pressure relative to atmospheric rather than absolute negative pressure, which is shown in figure 4. Equilibrium is reached when the air is returned to its original state. As a rough approximation, 1 kilogram of explosive produces about 1 cubic meter of gas. As this gas expands, its act on the air surrounding the source of explosion causes it to move and increase in pressure. The movement of the displaced air may affect nearby objects and cause damage. Except for a confinement case, the effects of the dynamic pressure diminish rapidly and with distance from the source. The ground shock leaving the site of an explosion consists of 3 principal components: a compression wave, which travels rapidly from the source; a shear wave, which travels rapidly and compromises particle movement in the plane of normal to the radial direction, where the ground shock wave intersects with the surface of a surface or relay wave. These waves propagate at different velocities and alternate at different frequencies. Architectural aspect of blast-resistant building design. The target of blast-resistant building design philosophy is minimizing the consequences to the structure and its inhabitants in the event of an explosion. A primary requirement is the prevention of catastrophic failure of the entire structure or large portion of it. It is also necessary to minimize the effects of blast waves transmitted into the building through openings to minimize the effects of projectiles on the inhabitants of a building. However, in some cases, blast-resistant building design methods conflict with aesthetical concerns, accessibility variations, firefighting regulations, and the construction budget restrictions. Planning and layouts. Much can be done at the planning stage of a new building to reduce potential threats and the associated risks of injury and damage. The risk of a terrorist attack, necessity of blast protection for structural and non-structural members, adequate placing of shelter areas within a building should be considered, for instance, in relation to an external threat. The property should be to create as much standoff distance between an external bomb and the building as possible. On congested city centers, there may be a little or no scope for repositioning the building, but what small standoff there is should be secured where possible.
Okay.
This can be achieved by strategic location of obstructions such as bollards, trees, and street furniture. Figure 5 shows a possible external layout for blast-safe planning. Structural form and internal layouts. Structural form is a parameter that greatly affects the blast loads on the building. arches, and domes are the types of structural forms that reduce the blast effect on the building compared with a cubic form. The plan shape of a building also has a significant influence on the magnitude of the blast load it is likely to experience. Complex shapes that cause multiple reflections of the blast wave should be discouraged. Projecting roofs for or floors and buildings that are U-shaped on plan are undesirable for this reason. It should be noted that single-story buildings are more blast resistant compared with multi-story buildings if applicable. Partially or fully embedded buildings are quite blast resistant. These kinds of structures take the advantage of the shock absorbing property of the soil covered by. The soil provides protection in case of nuclear explosion as well. The internal layout of the building is another parameter that should be undertaken with the aim of isolating the value from the threats and should be arranged so that highest exterior threat is separated by the greatest distance from the highest value asset. Foyer areas should be protected with reinforced concrete walls. Double dooring should be used and the doors should be arranged eccentrically within a corridor to prevent the blast pressure entering the internals of a building. Entrance to the building should be controlled and be separated from other parts of the building by robust construction for greater physical protection. An underpass beneath or car parking below are controlled. A possible fire that occurs within a structure after an explosion may increase the damage catastrophically. Therefore, the internal members of the building should be designed to resist the fire. Okay, Doctor. Now, Mr. Hussein Dakhil will proceed.
Yes, it is very good. For today, it is enough. Inshallah, next week you can continue.
Okay, thank you.
Ms. Abtahal is present. Mrs. Abtahal, I think, and Haida Tahir. You are present? Fatima Abbas Abtahal and Mr. Haidar Tahir, they are absent. Okay? Inshallah, you can continue this week. You're present. Okay, Khuda Hafiz. Ghazal Maran. Also absent. Hadi present. Okay.